So in this video we're going to be tackling exponential derivatives or derivatives of the exponential function. So if you remember y equals e to the power of x, there's not much to this. So if you have y equals e to the x, the derivative of that is going to be e to the x. I'm not making that up, that is something you can look up. So let's actually just start doing some examples here. So say if I had y equals e to the 3x. In our last video we did derivatives of composite functions where we used the chain rule, in which this would be our internal function. I'll put an I there, and that would be our external function, where you would have f of x being I guess e would be that, or something to the power of f of x would be something to the power, let's say y to the power of 3x, and then g of x would be our logarithm. So that, ignore this, I'm not 100% sure about that, but if you were to use the chain rule here, you would basically do e to the 3x times the derivative of our external function, which is going to be 3. So our derivative is going to be 3e to the 3x, because, let me see if I can get this right, if f of x equals e to the g of x, and my g of x is going to be 3x. Yeah, that's how it's supposed to be. So f prime of x, which is that, is going to be f of x times hold on. Yeah, f prime times g prime of x, which is basically e to the g of, when it comes to, logarithms. Sorry, exponential functions, you have e to the g of x times g prime of x. That's what I was trying to get at. So you can even do that with, say, e to the power of x squared minus x. Now you know how to do it. You just rewrite it and then multiply it by the derivative of the exponent, which is going to be 2x minus 1. Let's see what else we can do. Say we have f of x equal to x squared e to the x. We can use the product rule here. So we can put the derivative of the first one. 2x, times e to the x plus x squared times the derivative of e to the x, which is also e to the x. So now we can just simplify e to the x factored out 2x plus x squared. Simple as that. Let's try another one. F of x equals 3e to the x squared. Let's try to find f at negative 1, or f prime at negative 1. So, let's start by taking the derivative first. We can set the 3 aside and just do the derivative of e to the power of x squared. So we know that that's going to be x squared times 2x. So we should get 6x e to the x squared. And if you plug in a negative 1, you should get negative 6e. Because negative 1 squared will become positive 1e to the 1 is just e. And that'll become negative 6. So what else can we do? Let's see. While we're on the topic of exponents, I guess I could show you f of x equals b to the power of x. Let's see. If you have an exponent like this, then your derivative is going to be the ln of b times b to the power of x. So that's pretty straightforward, right? So if you have f of x is equal to 5 to the power of x, your f prime of x is going to be ln 5 times 5 to the power of x. Same with if you have f of x is equal to 5 to the power of 3x minus 2. You're going to have, let's see if we can use the, no, I guess not. I'm wondering if we can use the chain rule here. Because the f prime of x should give me, let's see, what do we have? 5. I know I have my ln 5 for sure. And then let's see if I can use the chain rule here, where I have f of x equal to 5 to the power of g of x, and g of x is equal to the x minus 2. So if I use the chain rule, hold on, I think I have that backwards. That should be b to the power of x. Yep. And then when I put it into the chain rule, I should have... Nope, I had it right the first time. So now, g prime of x is going to be 3, and the derivative of that is going to be ln 5. Yep, so I should have... I can write it down here. F prime of x is going to be the original times ln 5 times the derivative of the exponent, which is 3. And there you go. I guess that, this rule only holds true if it's just an x. If you have b to the power of g to the x, then your derivative will be f prime of x equal to the original function g of x times the ln of b times g prime of x. And I guess that made sense earlier when it was just b of x, because you would have b of x times ln b, and then the derivative would just be 1 anyways if it was an x. Okay, that makes much more sense. So, I hope that wasn't confusing at all. And yeah, I shall see you in the next one.